Today we are going to see about Rankine cycle, schematic diagram and T-s diagram. So what is the Rankine cycle? It is the pressure entropy diagram and the temperature entropy cycle. So in this cycle, it is commonly used in thermal power plant, nuclear power plant and biogas production and all. So it contains four components, that is boiler, turbine, condenser and pump. So in this Rankine cycle, this is schematic diagram for Rankine cycle, that is boiler, turbine, condenser and pump. These are the four units and the major components working towards Rankine cycle to improve the efficiency and the better output about the cycle. So in the thermal power plant, it is a common cycle. It is used in thermal power plant. That is, the water enters into the boiler, it gets into the steam and goes into the turbine. So initially from the boiler, the water is getting out as a steam. So water is converted into the steam. It goes boiler into the turbine. It contains only steam. That is superheated steam. That is superheated steam. அப்படினா என்னன்னா 350 degree Celsius க்கு மேல போயிட்டா it is known as superheated steam, that is T-soup. T-super it is mentioned as T-soup. So in this turbine, the electricity can produce using the rotation of the axle and whatever it might be. The turbine can be rotated through the help of steam and it produces electricity inside the turbine. There are three turbines are there, that is high pressure turbine, intermediate turbine and low pressure turbine. See, these are the three turbines which produces electricity through the steam, and the steam comes out as a steam and enters into the condenser and get condensed and is converted into the water. So the work has been done in the turbine and the steam is get out from the turbine and will go inside the condenser and it condensed through the condensing unit and it converts into water. So the water is get back into the pump. We pump the water from the pond or from the storage area. We send into the boiler. So here in the two lanes, that is 1 to 2 it contains steam, 2 to 3 is contains water, and 3 to 4 is contains water, and 4 to 1 contains steam. So through the pump, the water is pumped to the boiler. Again the process goes to 1 to 2 like that. So the boiler boils the water up to 2350 degrees Celsius. So about 100 degrees Celsius the water get vapor. We have to get the superheated steam. So up to 350 or 450 degrees Celsius we have to boil the water to get the superheated steam. So this is the efficiency formula that is worked out by heat supply. Before going to see this efficiency formula, it is a T-s diagram, that is temperature entropy diagram. The main concept is change in entropy or change in temperature is entropy. So it mainly depends on the temperature. So for example, the curve above the line is called a dry superheater. So below the line means it is wet steam. So it is a dry superheated steam that only produces the electricity through the turbine. So that is efficiency formula worked on by heat supply. The work done has been done in two places, that is the work of the turbine and work of the pump. So entire thing has been controlled by the enthalpy. So that is why we have mentioned H1 minus H2, which is the enthalpy. So first question to the second question. Turbine work has been starting from 1 to 2, that is mentioned as 1 and 2. So pump has been between the pressure of the first pressure and the second pressure. Before pump the water and after giving the increasing pressure. So that's only mentioned P1 minus P2. For V, that is called steam evaporation for the water. So இது வந்து ஸ்டீம்னால வந்து வாட்டரா மாறினதுக்கு அப்புறம் எவ்வளவு இருக்குன்னு பார்க்கிறதுக்காக பிரஷருக்கு உண்டான டிஃபரன்ஸ் பார்க்கவே நீ இன்க்ளூட் பண்ணிக்கிறோம். That is work of the pump. So heat supply has been done in only one process, that is boiler H1 minus H4. So first question is called steam and fourth question up to boiler. So H1 minus H4. So the net work done is W minus Tp. We have to mention the pump or not means we consider the pump, or otherwise we don't want to consider the pump. So the main concept of this Rankine cycle is increase the efficiency or improve the efficiency for in thermal power plant and nuclear power plant or biogas production. So this is the Rankine cycle schematic diagram and T-s diagram and its application. Thank you.